All right, thank you for coming to my talk. My name is Alex. I'm a platform engineer at a startup called On the Dot. We have around 30 engineers in our company. I lead a team of 5 platform engineers, and we work with all kinds of cool tech. This is our tech stack today. A few interesting things to point out. Our core system is set up as a containerized microservices on AWS. We use ECS, Amazon's proprietary scheduler. We use Circle CI for builds, Concourse for pipelines. We use serverless SAM, Terraform, CloudFormation, Scala for data engineering, TensorFlow for machine learning, and generally all kinds of interesting tech. So our startup has been around for about 3 years. And today I will tell you the story of how our observability evolved over that time. I'll talk to you about the considerations and the decisions we had to make throughout that journey. I suspect that our experience will be relevant not only to those of you who are startups with a similar profile to ours, but anybody who is kind of like exploring and navigating the landscape of observability today. This is the agenda. First, I'll tell you what I mean by observability. I'll spend some time looking at how this term's meaning has been shaped over the last few years. And then I'll spend the main part of the talk explaining how and why we went from basically nothing to what we have today in terms of our observability stack. For the purpose of this talk, I created a sort of a timeline of maturity of our platform, and I separated it into 3 stages. And this just to make it easier to think about the evolution of our requirements and our practices. Finally, at the end of the talk, I'll leave you with a summary and our learnings from this journey, as well as some predictions for the future of observability, and some time for questions. So the title of my talk is Balancing Observability and Agility in a Startup. And I chose to use 2 loaded terms in the title to kind of make a bit of a point. So the Agile framework has been around in our field for many years, so that most of you, if not everybody, will have heard of it. And the term Agile has a specific technical meaning beyond moving swiftly. Observability is a concept and a term whose exact technical definition is still being shaped today. So I wanted to spend some time exploring its formal definition. So I think it makes sense to start with the first hit you get in Google. This is from Wikipedia. It says, in control theory, observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. So really what that means is what data does our system give us that help us understand what exactly is going on inside it. So I think straight away it's clear that there's some sort of relation between observability and metrics, or monitoring. And especially when the term observability first started becoming really popular to wider audiences in our field 1 or 2 years ago, a lot of people argued that it was basically just a fancy rebranding of monitoring. And while it is true that the term can be abused this way, so somebody may try to sell you good old monitoring, but charge you double if they label it observability engineering, in truth, the 2 are quite different. And in fact, observability has been defined as a superset of monitoring for years. So Twitter wrote a blog post a couple of years ago where they described their observability team's responsibilities as being monitoring, alerting and visualization, tracing, and logging. So quite usually, we focus on 3 of those. Alerting and visualization kind of goes with monitoring for most of us, I think. And these 3, metrics, traces, and logs, have come to be known as the 3 pillars of observability. However, I wanted to emphasize that just doing those 3 things does not make a system necessarily observable. So for example, if you have an Elk stack and you're sending some logs there, if you have a Prometheus stack and sell some metrics there, if you have a Jaeger and you're sending some traces there, you don't necessarily have an observable system. In fact, I would argue if you have exactly what I described, you probably don't have an observable system. So you have to do certain things in a certain way, and this certain way depends on your context and on your requirements. There may be other things that you need to do apart from these three things, traces, metrics, and logs. And in some cases, you may not even need all three of those to have an observable system. And I think increasingly so in the future. You may be better off with just two or one of them. And I'll get into this a bit later. At the same time, the problem is not necessarily just technical. Because the journey to observability has to include instrumenting your services at the code level, it means it also has to include a number of software engineers in your company. So there's definitely a cultural aspect to achieving observability. So anyways, we're left with the question, what does it actually mean for a system to be observable, and how do I get there? And answering these two questions, basically I'll try in the rest of my talk to answer these two questions through the lens of what my team did. So as for balancing it with agility, at a startup like ours, engineers are expected to spend their time working on the main product that the company is building and sells, not observability, unless, of course, you sell observability. In an ideal world, maybe a young startup would have plenty of time to set up from the beginning a very good observability stack, future-proof, scalable, et cetera, et cetera. But in reality, we had to be strategic about when we can afford to spend time to work on observability tasks, and basically only do it when the timing was right. Right, so I said that I split up the timeline into 3 stages. That was a tiny bit of a lie, because I'm going to start with stage 0. So I'll talk about observability in a non-distributed system. So basically, in the beginning, our stack existed of a few containers on ECS. The logs lived on EC2 hosts. The metrics were on CloudWatch, kind of by default. There was no tracing. The overall context here is that there were only a handful of services and containers. There wasn't much going on. There wasn't too much pressure on our infrastructure. There weren't that many logs being produced. And it was easy to reason about the lifecycle of a request through our system because the architecture of the system was just so simple. It was like there's service A, so every request kind of comes in, hits service A, hits service B, and then some of them hit C or some of them don't. And that's it. So it's very easy to understand what's happening. So at this point, because it's such a simple architecture, you don't really need much to be able to understand what's going on in your system. So we're not very far removed from kind of like the world of a LAMP stack. So the ideas around observability in distributed systems don't really apply here. The explosion in popularity that the term observability has seen in the last couple of years is directly related to the fact that nowadays everybody's doing microservices, doing lots of containers, doing Kubernetes, et cetera. Without a distributed system like that, you don't really need a new paradigm for observability to be able to understand what's happening in your system. Right. Stage 1. So having said that, once you've bought into the microservices model, you want to basically start tidying things up because you're on your way to a complex distributed system. So at this point for us, our platform team consisted of 2 engineers. So the time that we could spend on kind of like observability tasks was quite limited. Either way, at this very young stage, one of the first things that you should do is aggregate your logs, and that's what we did in the beginning. So we picked one of the popular online logging platforms, and we started shipping our logs there. And we did this because we didn't want to have to take care of a logging stack in our own infrastructure because we didn't have enough time for it, basically. So these services are typically not very cheap, but for us, at that point, they were very cheap, precisely because we still had very few logs. So yeah. So this gave us a single interface through which we could inspect our logs. And this is kind of like one of the most basic requirements for this sort of setup. And if you're running containers or any sort of distributed system, if you don't have aggregated logs, surely you will know that that's a terrible pain. So one important detail here is that we committed to only stream logs. So stream logs as opposed to storing them on disk. So I think that storing logs on disk should be avoided because it's risky, it's error prone, and it's less flexible. So you should avoid it in favor of a streaming architecture. In fact, ideally, you have a streaming architecture that you can scale both in terms of how many logs you can push through it, but also how many types of logs you can push through it. So kind of like how many consumers and producers, different types of consumers and producers you can have. And how many types of data routing you can have. So for example, you may want to have application logs and database logs be handled differently, but it's nice to have a single logging pipeline in place that you can modify to support different requirements. So do take a moment to think about that, because this concept of thinking about a logging pipeline is a powerful one. And in fact, I think that setups based around an observability pipeline may become standard in the near future, and I'll get back to this later. As for metrics and tracing, so we wanted to prepare our system for the impending increase in customers. But also we had to continue running some legacy applications that needed a lot of memory. And I'll let you guess what programming language these were written in. So we definitely needed monitoring and alerting for those. So we went with Datadog, basically because it was the most popular logging platform at the time, or still is, I guess, in terms of online ones at least. And like I said, since our team was still tiny, we didn't want to have in-house infrastructure like Prometheus for this. Apart from the infrastructure metrics that we were shipping, we also started shipping some application metrics. But this was still unstructured. Only some developers did it, and so only some developers instrumented their applications to send metrics, and this was done kind of like randomly and sporadically. As for tracing, we still didn't have a requirement for that because the architecture was still very simple, but we were starting to realize that soon we would need basically a way to trace a request path through our system. One of the most important things that we started working on at that stage is we started working on a platform layer library, which allowed our users, so the developers in our company, to kind of like automatically integrate with our with stuff that we had set up in terms of like logging standards or metric standards. So we implemented those as wrappers that can go around something like your HTTP listen method in Go. And basically, they take care of a bunch of stuff for you, and they add tags and context and metrics for logs and metrics kind of like automatically. Right. So this brings us to stage 2. So stage 2 is when the number of services in our system started increasing. We started putting more customers on that system, and actually driving more traffic through our infrastructure. So at this point, we had aggregated logs, like I said, but these were only sometimes structured. So this was kind of like up to the developer. Since we now had more services and more traffic, you no longer have like 50 log lines that you can easily go through. Now it's like 2,000 log lines. So if you don't have structure to be able to filter by, you'll be wasting a lot of valuable time. So that's not good at all. So we came up with a logging standard and started encouraging developers to start using it. And this was more of a cultural challenge, again, rather than a technical one, in terms of we had to convince every developer to adopt our standards and keep working on improving their logs. So our requirements initially was that the logs need to be in JSON format, and that there are certain fields that we expect there to be there, like duration in milliseconds or status code. So many of the fields we prescribed were added kind of automagically just by the developer using the platform layer library that I mentioned. Other useful fields were added via CloudFormation and ECS task definition. So this is specific to AWS, but you can see basically this is how every service in our system starts. And by default, it will get a bunch of tags that are defined kind of like dynamically for everybody without the developers needing to do anything. So look at how rich this log is and how much information you can get about what is happening at that moment in the service. So this is from a machine learning kind of service, and you can see a bunch of information about the machine learning model there, like the model version, the data version. You can also see information about the CPU and the memory in use at that point. And you can see information about the user that made the initial request. The status code, the name of the service, the build number, the container ID, and all kinds of interesting stuff. So this is basically what we call structured logging. And when you do this, it means that you can parse things very easily and is critical without relying on regular expressions. It also means that you make sure you don't lose all the beautiful structure that you had in your application to begin with, right? So this is a pattern that I've seen many times, and it's a frustrating pattern. So the developers start building an application, and there's beautiful structure in it. You have your nice function names. You have well-named variables. But then when it's time to log, you tend to see an unstructured string that says something like user with user ID A encountered error B on his attempt to do action C, et cetera, et cetera. And then you have to write some custom logic to parse that, when in fact the structure was there to begin with in the application itself. So basically, don't do something like this. You can see this is a huge message that has all kinds of information in it. And it's hard to read both for a human and for a computer. Instead, do something like this. And I just rewrote this manually. This is not a real log, I guess. But you can see that I have this data field and then the fields within it. And you can see you know exactly what every bit of data basically means. And this is very, very useful both for humans and for machines. It makes it easier to process your logs and to gain insights from them and to filter them. For example, in this scenario, you can very easily, if you had a number of logs like this, you very easily say, I'm interested only in the logs where the duration in milliseconds is more than 2,000 milliseconds or whatever. Right, stage 2 metrics. So at that stage, basically, we wrote some scripts that could build Datadog dashboards out of a list of metric names. So what we would do is when a new service was getting deployed, a platform engineer would kind of like liaise with the application engineer who wrote the service, get a list of metric names, and then within a few minutes, basically, we would have a standardized dashboard that we could then use when we needed to understand the status of the service better or troubleshoot an issue. So after doing that, basically, I found that our actual use of the monitoring platform was mostly reserved for our legacy services, and not that kind of like operate on old paradigms, and not so much for the distributed microservices system. There, the lack of context on the metrics meant that we couldn't get as much value out of the metrics as we would have wanted. As for tracing, we adjusted our platform layer library to add a trace ID key in the logs of every service and propagate this trace ID as the request went through our system. So again, without the developers needing to do anything, all of a sudden, all our logs have this extra field with trace ID, which allows us to trace requests through our system. So this doesn't only help us to understand the life cycle of a request, but also when an issue happens, it's very easy to find where exactly in our system the error occurred. Additionally, we started investigating tracing solutions like Zipkin and Jaeger, both on their own and via service meshes. But basically, our conclusion was that the amount of effort and time that we had to put into those outweighed the benefits we could get from those. And more on this in a bit. So this brings us to stage 3. This is the final stage. And this is kind of like near to the present. So we've now had significant traffic for a while. Dealing with logs is actually, and logs and metrics is one of our main expenses. the initial solution of just find a popular online platform was no longer good enough. So we have to start thinking about how we can lower our costs, but also how we can make better use of the rich context that we're gathering, like in that rich log that I showed you before. And the amount of observability data that we're collecting now is a problem on its own. Right, so logs. So when our logs became tens or even hundreds of gigabytes per day, this became very expensive. So we had to reevaluate. So at this point, we had a larger platform team. We had more people, more time to work on this. So we could have kind of like a in-house solution, maybe something like an Elk stack. So the Elk stack has been a standard for many years. After all our stuff is on AWS. AWS offers a managed Elk stack service, so it kind of made sense. However, I knew that even so, the Elk stack would come with significant operational overhead, which I didn't necessarily want. So out of curiosity, has anybody here managed or supported an Elk stack? OK, there's a few people here and there. Did you enjoy it, or did you find it easy, difficult? No, I'm seeing some no. All right, yes, that's my experience, basically, that most people I know that have had to manage Elk clusters didn't really enjoy it that much. So like I said, we were trying, one of our main motivations was to cut costs. So another possible solution to cut costs would have been to work on sampling. So basically what this means is, let's say you have a service and you have 100 requests to it, 95 of those are successful and 5 of them are errors. Do you really need to see each individual log of the 95 successful requests? Not really. So basically, you drop a bunch of the successful ones because you have a lot of them. You don't need all of them. And you keep mostly the errors, which are what you are more interested in. So this would definitely cut costs. But I decided this wasn't the direction I wanted to go in just yet. So just to recap, our requirements was to cut down costs, don't do sampling, we want to continue streaming logs and not store them on disk. And we probably still, again, wanted to use an online service to avoid the operational overhead. So our search led us to Humio, a startup I had heard of in the past. So they have a bespoke database, which means basically that they can deal with larger volumes of data without the costs skyrocketing like they tend to do with the Elk stack. They're also a member of the CNCF, so that kind of played a role in our decision as well. I also decided to use FluentD to aggregate logs in our internal infrastructure. Again, FluentD, member of the CNCF, that was important as well. For FluentD, with Kubernetes' roaring success, the FluentD, basically the EFK cluster, or the EFK stack, is a standard there with FluentD. And I wanted to kind of like learn the ins and outs of that piece of software in case we ever move to Kubernetes. But also, it really makes sense within the context of the logging pipeline that I mentioned before. Anyways, in terms of the logs themselves, I talked about how we worked on adding lots of context and tracing information. So this effort continued iteratively until we now have proper traced, structured events with rich context and metrics. And this is basically logs on steroids. The actual application log is only a tiny bit of what the log ends up being, which is a huge data structure with all kinds of different information, right? And we saw things like the CPU and memory utilization during the call, or things like the session ID, the user ID, and all kinds of useful fields to slice and dice by later. Metrics. So we don't have any dashboards or monitors on the walls or anything like that. We mostly use our metrics to investigate things kind of like ad hoc, to figure out what the status of a service is or to troubleshoot an issue. So in order to make sure our metrics remained as relevant as possible, basically, one of the main things we wanted was to increase the granularity of the information we could get out of them. So traditionally, metrics aren't very multidimensional. So a graph that shows you basically the successful versus failed requests for a service can be useful, but it's not very useful if you have essentially a very small logical subset of users that is seeing errors. And it's such a small number that it doesn't show up in the big aggregated graph, but it is significant for that logical subset, right? So an example from our experience is we had one customer who was doing their onboarding. And basically, they said that they were getting bad responses from one of our services. Our dashboard showed that everything was fine. Almost all the requests to the service were good. So that 0.1% of a request that user was trying to do during onboarding didn't show up in the aggregated metric. So basically, to be able to have the visibility that you need in order to figure something like this out, basically you add tags to your metrics. So we started by adding a tag for one of the main filters for us, which is our customers. So we have a finite number of customers. I don't know the exact number, but let's say it's around 20. So basically, every time one of our services emits a metric, they add a tag which says which customer this function was running for. So basically, when we split up our metrics by customer with that tag, it was very easy to see that basically all of the customers were doing just fine, but that one customer had issues. So then from there, it's easy to go and figure out what the actual bug is and fix it. So here, I have a quote from a very quotable blog post by Baron Schwartz. And he says, using traditional tools to measure, inspect, and troubleshoot customers' experiences is basically impossible because of pre-aggregation and cardinality limitations, and leads engineers to focus on what the tool can offer them, which is often the wrong place to look. So as it turns out, most time series databases are not really made to handle tags with high cardinality. So that means if you tag your metrics with something like a session ID, which can have tons of different values, it's not designed to handle this very well. So that's not really a good idea. In fact, for Datadog, which is what we use, there are limits to the amount of distinct metrics you can have, and this depends on the plan you're on. And if you were to tag a very high cardinality field, you would easily exceed that limit, basically. And another quote from that same blog post, it says, traditional time series software was designed with an internal-facing sysadmin worldview in mind, where we inspected our own system servers and cardinality was naturally low. So what I'm trying to say is that with regards to monitoring, we hit kind of like a limit in terms of functionality we could get. And this limit, I think, is a significant way in which monitoring and observability are different. So this is about the fact that if you can't introspect your system based on high cardinality fields like session ID or user ID, then you're missing out on a lot of context and potential that as an industry we should be able to tap. So in the past, as a sysadmin, you had to make sure that the system was up, but this concept doesn't really make sense in a distributed systems scenario. So instead, we need to be able to check and confirm that individual requests are successful or individual traces are successful. So this was the barrier that we hit, and I'll tell you in a bit what that meant for us. However, I should say that we didn't stop looking at groups of metrics or looking at our dashboards and trying to scan for potential changes in changes or spikes, et cetera, which from a purist perspective may not be ideal, but it is what it is. And now tracing and AWS X-Ray. So we decided to work on instrumenting our services with AWS X-Ray. Like I said, we use only AWS. All our languages were supported by X-Ray, so it made sense. So this did give us some benefits, but it didn't really change the way we troubleshoot issues. The main benefit that we got out of it is that it helped us identify some things that we didn't really know, like, oh, that service talks to that thing or that service. And the service graph visualization is basically a nice thing to get and review. So if you've never seen something like this, it basically just shows the traffic between service to service, and each kind of like one of these circles that represents one of our services. So obviously, it's very easy to see that the one on the far right is having an issue. So we get this sort of visualization because we were able to instrument all the HTTP calls at the platform layer library level. So again, with zero work from developers, we automatically get basically this. As for instrumenting individual functions, this is a potential task for us for the future, but it's both technically and culturally challenging. Yeah, it's definitely not a trivial task to get owners of 50 or more microservices to all consistently instrument their functions, or to coordinate context propagation between all of those things consistently. Furthermore, I found that there's still some loose ends in terms of where the industry stands in terms of tracing. There's the open tracing and open census tracing libraries. They're the two most popular ones. It's not clear to me what the point is of having two separate projects that are so closely aligned and so that have so much overlap, and I'm kind of waiting for them to merge. And if I were to kind of like design a tracing solution for myself right now, I would probably be tempted to use a minimalistic solution, a homemade one, I guess, like this fellow engineer did. So either way, bottom line is that while there are certainly insights that we could gain from distributed tracing and tracing at the function level, based on our requirements, we haven't really needed this so far. So this goes back kind of like to the balancing act between agility and observability. For us, the tracing that we really needed was the trace that we got at the logs with the trace ID field. So the traces at the function level is not something we really needed. Obviously, your mileage may vary. Right. So summary and learnings, AKA Alex's 3 pillars of observability. So where does this leave us? So our logging platform remains our most useful tool. And that's because of the attention we've paid to not just shipping logs, or not just shipping logs, but shipping structured events with rich context, with high cardinality fields, and tracing information, and built-in metrics. So this is the stuff that makes boring old logs into a superpower that allows you to look into a request or a specific user's journey through the system and be able to understand what their experience is like. So I've put here rich context, tracing info, structured events. So having enriched our logs this way, they're so powerful that our need to rely on our metrics and our monitoring and tracing platforms is not self-evident. We can slice and dice a million ways to answer the questions we come up with during a troubleshooting session. So you can see here that basically from my logs, I could create an ad hoc visualization of metrics, right? Which depend on the trace ID. You can see it's there as a parameter. So basically, you have this combination of logs, metrics, traces. So yeah, this is basically instead of having a list of predefined dashboards that you look at when something goes wrong, and you just scan through them and look, oh, is there a spike there? No. What about the next one? No. What about the next one? Et cetera. Which, like I said, I'm not a purist about this. In some cases, it may still be useful, but probably in a lot of cases it will be suboptimal. So anyways, I think if you get these 3 things, the tracing info, the context, and the events, you've at least set a great foundation for yourself. After that, it's all about processing and visualizing the wonderful data that you've collected. By the way, if you're thinking, what exactly do you mean by events? Because I mentioned events as opposed to logs. Or if you're thinking, hey, my logging is expensive enough already. If I add all this rich context that you're telling me to add, it will get much, much worse. Well, there's one more paradigm shift that I didn't explain. So typically, what I've seen in the wild, when people log basically stuff, what they do is you have this microservice, a request touches it, it goes through the functions within that microservice, and at various places of interest, you would add basically a logging, basically a request to log something. And at the end of the request cycle through that service, you would end up with like 3 or 5 or 10 unique logs for this request. So obviously, you're getting a lot of duplication of data. You have tags, for example, that are tied to this request. And for every single one of these individual logs, these are repeated again and again. And this gets much worse if you have all this rich context and you repeat it 10 times for a request where you know that all these things around remain the same, right? So instead, what you should be doing is this. One trace equals one log per service. So every time a request hits your service, instead of logging 10 different times, you keep track of what you wanted to log, and you only emit the log at the exit point of your service. So basically, you don't lose any of the logging that you were doing, but you just emit it in a single exit point. So this ends up being a great solution for that. Right, the future. So in terms of the future of observability, as is evident from the talk, I think it takes time and effort and careful thought. There's a lot of questions to ask. The answers are not clear always or crystallized. The 3 pillars of observability are what our industry has come up with, basically to help us introspect over our systems, given the existing technology that we have. But like I said, from our experience, it's not self-evident that you need these 3 things, and especially not these 3 things separately on separate platforms. I think we're approaching the point at which instrumenting these signals, or better signals, should not be a pain and should not be an exercise in reinventing the wheel. And I say this because I know that a lot of other companies have gone through a similar journey in their quest for observability. I would not be surprised if the observability pipeline became a de facto standard in the near future, something like this. I took this design from a great blog post that came out just a few days ago, actually, and captured a lot of my thoughts on the matter better than I could. And then I have another quote from another beautiful blog that it's also very, very recent. It says, "The right path could accept raw events, demux them into metrics, traces, and logs heuristically or by the shape of the data, make the relevant optimizations, and store them into purpose-driven backends. The read path could provide a single pane of glass-style interface abstracting over those backends." And this is quite a mouthful, so you may need to read it a few times to really get what it says. But basically, I would not be surprised if in the next few years, instrumenting your code for traces, logs, metrics, or something better, were trivial and achievable via a single path. So after all, traces, logs, and metrics are just different sides of the same coin, right? They're just data that tells us what happened. So I think we should be looking to abstract it into a sort of like Uber face, a single signal that captures all others. So to be honest, this is kind of like already happening. The really rich logs with trace IDs and with information about CPU and memory that I showed you are very clearly moving in this direction to combine the 3 signals into one. So I see no reason why vendors and open source tools going forward won't provide you basically processing backends and some front end that will allow you to get what we currently get from 3 different places, but instead this time get it from only one. And this will definitely also help avoid the serious duplication of data that goes especially between logging and tracing platforms that I've seen in the wild. So that's it from me. I hope that you enjoyed my talk and got something useful out of it. This presentation will be available on this link. Thank you very much. I think we have a few minutes for questions.
5 minutes.
Hey there. You mentioned a platform library earlier on. Unless I missed it, can you go into more detail on that? Can you elaborate on what that platform library was?
Yeah, sure. So this is basically a bit of code that our team wrote in cooperation with developers. And this is something that essentially developers, when they're building applications or building other services, can import into their code and just out of the box get a bunch of stuff that we had predefined for them in that library, right? So what this does is it helps them, or basically what it does is without them needing to do again everything that we've done. We do it once in one place, and then they import it, and it's automatically done for them. That's kind of the idea. Does that answer the question? Yeah.
Hi there.
Hey.
We've found that using log stream handlers to stream our logs have had a significant negative impact on performance for our applications. Have you had a similar experience, and have you managed to solve that?
Can you repeat again, using what?
Log stream handlers. So streaming your logs over HTTPS.
Right. So we don't necessarily, so the streaming happens at the FluentD level, right? So the applications push the code the logs kind of locally to the FluentD agent that lives on that node, and then the FluentD does the streaming to the other bit of the infrastructure.
Okay.
Yeah. Any other questions? No? All right, cool. Thank you very much, guys.